So guys, it is in continuation with my previous video. I am still solving various questions. So I'll be starting from question number 4 to question number 6 in this video. So as per question number 4, what they are saying, let's see. As per question number 4, this is the graph, displacement time graph. This is displacement time graph for question number 4. I have shown clearly, right? What they are talking about is that the displacement of a body, this particular graph they are describing. Uh, this graph shows the displacement of a body at different times. Displacement of a body at different times, right? Calculate the velocity of the body as it moves for time interval. First part. Okay. So question number 4, part A. Part A is part 1. What it says? It says calculate the velocity of the body as it moves for time interval 0 to 5 seconds. So 0 to 5 seconds, what is? Can we comment? From 0 to 5 seconds, if you see, right, the slope is constant, so body is in uniform. Body is traveling with uniform velocity, right? Right? So velocity from the first as velocity is displacement upon time. What is the displacement in 5 seconds? 0 to 5 seconds, it is 3. And what is the time? Height. What is the velocity? 0.6 meter per second. The velocity is positive. That means, suppose this is the starting position, right? I am writing it later as the body started from this position and it is a linear motion. We are discussing numerical problems related to motion in one dimension. So body is continuously moving away from the initial position, right? This can be one of the things, right? What is second part it saying? Second part of problem A says that find the velocity. Calculate the velocity of the body as it moves for time interval 5 second to 7 second, right? So in second case, we will again calculate velocity, displacement by time. In this case, from 5 second to 6 second, 5 second to 7 second, if you see, which is indicated in red, right? 5 second to 7 second, the position of the body is not changing. Its displacement remained same. That means after reaching 3 meter from the starting position, after reaching 3 meter for the starting position, the body is at rest for 5 to 7 seconds. So here you can say the displacement remains 0, right? No displacement, no movement. So displacement you can say 0 upon t. That will give you 0 because body is not moving. What is the third one? Calculate the velocity of the body as it moves for time interval 7 second to 9 second. That's it. 7 second to 9 second. In this case, again, displacement by time. In this time period from 7 to 9, which I have indicated in red, which I have written in red alphabet, right? At 7th second, the position of the body is 3 meter from this, right? And at 9 second, the position of the body is at 7 meter. So it will be displacement will be 7 minus 3. Okay, right? Okay, and the time is 9 minus 7. So 7 minus 3, 4. 9 minus 7, 2. So it gives you 2 meter per second. Are we clear? Yes. Also, it is quite evident. For 7 to 9 seconds, right? At 7 second, the position of the body is at 3 meter. At 9 second, the position of the body is at 7 meter, right? So this is what I have calculated here, and the velocity is coming 2 meter per second. One more thing I would like to add from my side. if you compare the velocity in part 1 and part 3, you will see that velocity in part 3 is more than that of part 1. Mathematically it is also true because the slope is higher in this case. Because if you go and calculate the slope, this will be higher. This is much more than this slope. Right? This slope is much more, slope is high. So velocity is high. Right? So let us see the next part, B part, what it says. It is asking us to calculate the average velocity during the time interval 5 second to 9 second. They are asking us to calculate the average velocity from 5 second to 9 second. So it's a B part. We have to calculate average velocity. Right? So V average, we will calculate average velocity. So from 5 to 7 seconds, there is no change in the position of the body. So ideally, the body does not move from 5 to 7 seconds. But from 7 to 9 seconds, the position of the body changes from 3 meter to corresponding to 7 meter. Right? So it will be total displacement. Right? Total displacement by time elapsed, by total time elapsed, by total time elapsed. So can we calculate the total? What is the total displacement in this? Between 5 to 9, between 5 to 9, what is the total displacement? It is, we can calculate 7 minus 3. 7 minus 3. What is the time stamp corresponding to this? 9 minus 5. 7 minus 3, 4. 9 minus 4, 5, 4. So it is coming 1 meter per second. So this was all about problem number 4. Question number 4. So let us see the second problem. Here again they have given displacement time graph. Displacement time graph, right? So here body is traveling at c 2, 4, 6 time in second, displacement in meter. This is something which is shown, right? So it is saying that about this graph, it is written that from the displacement time graph of a cyclist given in this particular diagram, find the average velocity in first 4 seconds. Find the average velocity in first 4 seconds. So it is part 1. Average velocity in first 4 seconds. Find the average velocity in the first 4 seconds. Okay. In the first 4 seconds, what is the, you said it is somewhere crossing this, right? So total displacement, by total time elapsed. Okay. So total displacement is what? Total displacement in this case is from 0 to 10. You can say it's a 10, right? And what is the total time elapsed? It is saying from 0 second to 4 second. 4. It is coming 2.5 meter per second. It is positive, that means the body is traveling from away from the starting position. Right? Here. Okay. Now it is asking in the part 2. Second part is asking the displacement from the initial position at the end of 10 seconds. The displacement from the initial position to the end of t equal to 10 seconds. T equal to 10 seconds is here, right? So what do you see at the end of, at the t equal to 0, the displacement was 0, right? It is coinciding, right? 0, 0, 0. It was at origin. At the end of 10 seconds, its position is minus 10 meter. So it is asking displacement. So displacement, you can say displacement is what? Minus 10 meter, right? Minus displacement means the body has moved rightward direction. So we are showing with the positive sign, and then body must have returned back to the initial position, starting position, as we are seeing here at the 7th second, and after that it went back in this direction, right? In this direction, this is minus, so that's why it is going in the reverse direction. It is going in the opposite direction, right? Okay. Third thing. What is the third part it is talking about? The time after which he reaches the starting point. The time after which he reaches the starting point. Okay. What we can say that? So we can say that what is the time at which it is started? So that is 7 seconds. At 7 seconds the position becomes starting, and from this graph 13 second, right? So at 7 second and 13 second the position of the object becomes 0 at the starting position, right? Just a moment please. Now go on to Spain. Okay, now question number 6. Here again displacement time graph is given. Displacement time graph is given. Okay, and in this case there is a little bit difference. Time we have taken in, time is given in r, and displacement is given in kilometer, right? Displacement is in kilometer and time is in r. Okay, so as per the question what they are asking, I had written the displacement sketch of motion of two cars A and B, right? So from this, what we can say about the position of car A and car B? It is motion of two cars A and B, right? So we can say that car A was, so at the beginning from this at the beginning of the time, right? So car A was at 0 position and car B was at 40 kilometer, right? So car A is here, right? This A car which is at 0, right? And car B is at 40 meter ahead of this, 40 kilometer, sorry. It is at 40 kilometer ahead of this, right? 40 kilometer ahead of car A. This is what is shown here, right? And what they are asking? They are asking the distance by which the car B was initially ahead of car A. What is the answer? This you can easily answer. That is, by how much kilometer car B was ahead of car A? 40 kilometer, right? What is the second part they are talking about? They are talking about the second part, the velocities of car A and car B. You can find out the velocity of car A. Let's find out the velocity of car A. What is that? This is displacement of car A upon time taken by car A. So we are seeing this particular picture, okay? So we have to calculate the velocity of car A. Car A, okay? So this becomes, if you represent this point by A, this as B, okay, this point as C, this point as D, right? So velocity of car A means, car A is this, we are talking about this particular slope this, right? This slope is DC by AC, right? What is the value of the DC? DC is 80, and what is the value of AC? AC is 2, so it is coming 40 kilometer per hour, okay? And what is the velocity of car B? Car B is this, right? So for car B, we need to plot an extra line of this parallel to this. So this is this let us take this as E, right? So for car B, the slope is this. So displacement made by car B by time taken by car B. Displacement made by car B is C. This distance, this particular distance is 80 kilometer, right? D to C, and E to C is same as 40 kilometers. So DE is 40 kilometers. This is 40 kilometers. Okay, and this is again 40 kilometers. Quite clear? This is 40 kilometers, right? And this is 40 kilometers, and this remains 40. So this is 40 by 2. It becomes 20 kilometer per hour. Okay. Now they are saying the time in which car A catches car B. At what time car A catches car B? Car A catches car B. From this graph we can see the point of intersection. We have to find the point of intersection. So where is the point of intersection? Point of intersection is D. So it is 2R, which corresponds to 2R. Okay. And now the last part, what it says? It talks about the distance from start with the car A will catch the car B. Car A catches car B after it crosses 80 km. Right? At this point. So the answer is 80 km. Okay? Thank you.